Morning, everyone. I know that there are still people trickling in the room right now, but we can go ahead and get started with some of the introductions here. Well, welcome. Thank you for joining us for our April session. We're really excited to discuss our topic on reducing embodied carbon in design, benchmarking, timeline, and SE 2050. I'm Rachel Nicely, and our speakers today are Lauren Wingo, Senior Structural Engineer at Arup, and Kirsten Smith was Sustainable Program Specialist with Sustainable Building Partners. Go to the next slide. This is the Washington DC Hub of the Carbon Leadership Forum. The Carbon Leadership Forum, or CLF, was developed to organize events that empower industry professionals to radically reduce embodied carbon from buildings and infrastructure. The CLF is a group focused in these 4 areas: research, resources, network, and initiatives. And we're happy to discuss any of these areas with you and kind of grow our team here in our local chapter. So if you have any ideas or any initiatives that you'd like to kind of be a part of, please feel free to contact Kirsten or myself. And to do so, here we have some opportunities to collaborate. We have our website listed here. Please make sure you subscribe to our mailing list through the website. We have an email address here. The forum is an opportunity to pose questions and create an opportunity to discuss any topics that you have of interest. And then we have our LinkedIn group. Please be sure to join the group where we'll provide information and can have a forum to share our ideas. If you're interested in volunteering, please reach out to Kirsten or myself. So let's get into it. Kirsten is going to take us through benchmarking and timeline, and Lauren will give us an introduction into what's going on with the SE 2050.
Great. Thanks, Rachel. Good morning, everyone. My name is Kirsten Smith. I am a Sustainable Program Specialist at Sustainable Building Partners. And I'm responsible for facilitating green building certification of our projects, as well as developing and implementing services in support of sustainability goals. Over the past couple of years, I've worked to build up our life cycle assessment services, which has made me very passionate about the topic of embodied carbon. I know we have a lot of others here passionate about the topic, and I'm excited to hopefully work with and learn from you in the near future. Just a quick note about SVP. SVP is a multidisciplinary firm with our core services being sustainable program consulting, commissioning, and building performance. We provide various different services to consult a variety of rating systems and codes. Related to today's topic, we perform whole building lifecycle assessments, often using LEED as the framework for demonstrating reductions in environmental impact. With the topic of reducing embodied carbon in design, I'll be focusing on benchmarking tools that we have available to us now and how we can use those tools to evaluate materials to set carbon reduction goals throughout design. Lauren will touch later on some of the great benchmarking tools that will be available to us in the near future, which I'm very excited about. I'll be presenting from the perspective of a sustainability consultant and our methodology to reduce embodied carbon in design. As a consultant, we are in the unique position that we are not necessarily responsible for the design and materiality of the building. We are facilitators that provide information and help teams make decisions. We strive to balance with what is innovative and what is feasible. And oftentimes our conversation starts after a bulk of the design decisions have been made. So where do we go from there? I'll touch on some tools that we can use for benchmarking and design and the ultimate goal of setting targets and incorporating impact reducing material selections and specifications into the project documents that are transformative and progress decarbonization of the built environment. So first things first, how do we know what is good, what is our target, and if we are on the right path? A benchmark is a standard or point of reference which things can be compared or assessed. Benchmarks allow us to evaluate where we currently stand compared to the standard or encourage us to set goals to do better than what is considered standard or industry average. Related to what we're talking about today, benchmarks can encourage us to reduce our carbon footprint of our buildings. So what can we use now? We are able to compare some materials using EPDs and tools that are available to us now. Carbon emissions for materials is becoming more and more available. With tools and resources like EC3 and the Carbon Leadership Forum's material baselines, we're able to compare materials with EPDs and select those that have a reduced environmental impact. A quick disclaimer though, these tools are very useful, but the industry is still missing a lot of data. And that's where we come in. We need to be encouraging impact reporting, both for the manufacturers on the material level through EPDs and from the design teams on the whole building level. We're especially missing data on the whole building level. And Lauren will touch on this more in a little bit with some of the great things that SE 2050 is doing. The more data that exists, the easier and more accurate setting embodied carbon reduction goals will be. But as I mentioned, there are some pretty great resources available now that we can use to start comparing materials. Carbon Leadership Forum released their recent Material Baselines report in January of this year, which is an update to their previous beta material baselines. The report includes carbon emission baselines for materials like concrete, steel, wood, insulation, and some finished materials. The baselines are sourced from data provided by trade associations like the Gypsum Association and the American Wood Council, either by industry average EPDs or other industry average data. We see these baselines pop up in benchmarking tools such as the Building Transparency's EC3 tool. LEED has also introduced a procurement of low-embodied carbon construction materials pilot credit, where the intent is to show a reduction in the embodied carbon of materials used in the building when compared to the CLF material baselines. So the CLF material baselines is a great resource for us to be able to compare materials against an industry average and make more informed decisions on our material selections in terms of embodied carbon. Here's a snapshot of what the CLF material baselines tables look like. They're outlined by material categories such as insulation, concrete, and steel, and are further broken down by material subtype here. 3 different embodied carbon baseline levels are provided for each material subtype, like low or achievable, the typical or the median, and the baseline or the higher level, based on industry average carbon emissions data. Some subtypes show a wider range between the achievable and the higher baseline values due to the variety of materials included. For example, in the insulation table showed here, the board insulation subtype includes mineral wool and EPS, which have varying carbon footprints. The EC3 tool uses the achievable low or lower CLF baseline figures in the benchmark to encourage movement in the industry toward materials with lower carbon emissions. The Building Transparency's EC3 tool takes the CLF material baselines and creates an interactive tool that can be used to compare materials with EPDs against the industry average benchmark. Here's an example looking at XPS board insulation on how less carbon intensive product can be chosen by comparing material options. I've used the example of the original Owens Corning foamular insulation as an early design option that is a typical chosen XPS insulation in the industry. However, if compared during design to other available products, we can find that we might be able to get closer or even lower than the baseline. You can see that on the EC3 box plot, the original foamular XPS insulation, which we're showing here as our early design option, hits on the conservative end of the graph, whereas the new foamular NGX product hits the lower achievable end of the scale, below the CLF baseline. This is an easy example because Owens Corning has recently optimized their original foamular product and released their NGX XPS insulation that uses a different blowing agent, resulting in a significant reduction in GWP without any change to performance. But we can also use this tool to explore other material and manufacturer swaps. Comparing different material types, brands, and products against each other and against a benchmark is an important step in design to reduce material embodied carbon. In addition, we will likely to start to see more of these optimizations with materials in the industry. So it'll be important to stay up to date with newly released products that result in a reduction in embodied carbon potential or global warming potential. Again, it is important to request EPDs from manufacturers so that tools like EC3 have more products and more data to compare. The Sustainable Mines Transparency Catalog, which many of us use to find EPDs and other sustainability documents, is another tool that can be used to quickly compare products based on their embodied carbon. The Transparency Catalog reports results from the EC3 tool for products listed in their database. Results are listed as a percentile, showing where the product lands compared to others in a similar category. We can see from the Transparency Catalog database that our original foamular NGX or foamular XPS insulation is over the 60th percentile, meaning that more than 60% of products in a similar category have a lower embodied carbon value or kilogram CO2 equivalent per declared unit. Okay, so with many materials we use in our buildings, comparing EPDs or against an industry average benchmark is a good way to understand how our products perform in terms of their carbon footprint. However, concrete can be a little trickier since it's a complex product with a lot of variables. The materials within our mixed designs, such as aggregate, can vary based on location. We have many different mixed designs to meet any and every performance requirement, such as compressive strength and exposure class requirements. In addition, the concrete PCR, or product category rule, does not include all performance requirements. It only requires the concrete mixes be categorized by the 28-day compressive strength. This means that there are a lot of other variables that are not being captured in a concrete mix EPD, making them difficult to compare. Most importantly, there just isn't a lot of data available to compare concrete mixes. Although there are some manufacturers in the area that have started creating product-specific EPDs for their mixes, such as Vulcan and Aggregate Industries, it has been slow-moving in the industry. This is likely due to the sheer volume and variety of mixed designs, meaning manufacturers would have to acquire a lot of EPDs. All of these factors make comparing concrete mixes just a little bit more complex. So what is available to us and what can we start doing now? We do have the NRMCA ready mix concrete benchmarks that are available to us. These benchmarks are comprised of industry average data from concrete manufacturers across the country. Even better, the NRMCA has categorized the data into separate regions, which can help to account for the materials available in those regions. For our projects in the DMV area, we can use the Eastern Region benchmark as a guide to see how our mixed designs compare against the industry average data in our region. Although the NRMCA data still does not account for variables other than 28-day compressive strength, it is currently the best ready mix concrete benchmark for our area. There is also a tool available to help us compare our project-specific mixed designs against the NRMCA benchmark. The ZGF Concrete LCA tool is a free interactive tool available to anyone that was created by ZGF architects and using data from NRMCA and Tally. It allows you to enter the pounds per cubic yard of the mixed design components, and then the tool compares your mix to the NRMCA benchmark, whether that be national or regional. The tool can be great if comparing different concrete mixed design options for a specific function or getting an idea of what the concrete environmental impact and carbon footprint might be for the project. It can also help to set project goals and for reducing the project's concrete impact. At SVP, we are starting to use this tool to collect data on the mixed designs in our area to get an idea of what is available. We hope to eventually be able to use this information to find concrete benchmarks for the DMV area. Another great way for us to compare our concrete mixed designs is to focus in on the cement used. Because cement is responsible for around 90% of the carbon emissions associated with concrete, it can be a good indicator on the environmental impact and carbon emissions of the whole mix design. With less variables in cement than in the concrete mixes that we use, it can be an easier way for us to compare and optimize our concrete mix designs. As I mentioned earlier, one of the market considerations relative to concrete EPDs is that you need to create one for every mix for every plant, and that's a lot of EPDs. There are EPD generators becoming available to help streamline this process, but it's just still a lot of EPDs. This is where cement EPDs become important. Although there are not many cement EPDs available in our area, they will likely become available soon by the cement manufacturers around. We can compare product-specific cement EPDs either to the Portland Cement Association's industry average or to other products available without the variability that comes with the whole concrete mix design. Cement EPDs can provide clarity on how a mix design will perform, and it's an important part to creating low carbon concrete. Bringing it back to what we can do now, we can start to request cement EPDs from our suppliers so that they become more available in the market. Something else that we are trying out at SVP is facilitating more communication and collaboration between the structural engineer and the concrete supplier on cement management within the project-specific concrete mix designs. We have created a low cement concrete worksheet, which encourages both the structural engineer and the concrete supplier to propose a mix design that meets the performance requirements set by the structural engineer. The tool then focuses in on the cement content of each proposed mix and compares it to the cement content of the NRMCA benchmark. A visual representation of how the concrete mixes compare in terms of cement content and GWP is also provided. This tool is meant to be used to compare cement content against a benchmark and spark more conversation on cement management practices and strategies that can be incorporated into project-specific mixes. So we've talked about some of the tools available to us for benchmarking and comparing materials. So how do we use them to evaluate and set carbon reduction targets throughout design? And who should be involved in the embodied carbon conversation at each design phase? As with many things associated with design, we can have the most environmental influence the earlier we start to evaluate the project's impact. Conversely, the further in design that environmental impact is evaluated, the higher cumulative costs there may be to reach embodied carbon or environmental impact reduction goals. However, even if a project is already in the later phases of design, there are always materials that can be evaluated and optimized based on their environmental impact. Ideally, though, we can evaluate material embodied carbon at every phase of design and facilitate collaboration between all parties throughout design. Every player has the ability to reduce the overall embodied carbon in the building, and oftentimes it takes the collaboration between multiple parties. Here's a timeline that we use as an outline for what we can evaluate at each stage of design. At schematic design, looking at overall massing and structural components. In design development, focusing in on the building hotspots or the most carbon intensive materials and elements. Once we hit construction documents, we incorporate impact reducing language into the project specifications. And in construction, submittal reviews can be performed to ensure material selections and carbon reduction goals. You'll see that I carry this graphic of collaboration with all parties throughout the next couple slides. And that's because all players can be very influential at every phase. Systematic design is where the greatest environmental influence can take place. Evaluating different massing options and structural designs can be huge when setting embodied carbon reduction goals. There are many strategies that structural engineers can incorporate into their design to reduce embodied carbon. Our CLF Washington DC group plans to have another event soon as part 2 of reducing embodied carbon in design to look at some of these strategies. In terms of benchmarking and comparing the carbon impact of different design options at this early phase, there is not a lot of data yet. However, there are organizations that are working to collect data and be able to provide tools for benchmarking. One of those organizations is the Structural Engineering Institute's SE 2050 Commitment Program, which Lauren will talk about in a little bit. As we move into design development, we can evaluate carbon hotspots in the design or certain components that are carbon intensive and may allow for opportunities to reduce impact. We can evaluate facade and finish options, different types of insulation, some structural elements if still under design, and concrete components where cement management opportunities may be feasible. This is the phase of design where we can evaluate materials using the tools available to us to make decisions on materials with embodied carbon impacts in mind. In the construction documents phase, we may still be evaluating opportunities in the design and material selections to reduce embodied carbon, but start to make finalized decisions on some of those materials. Impact reducing language can be added to project specifications to ensure that carbon reduction targets are realized in construction. Carbon reduction goals can be set and communicated through the specifications for targeted materials based on benchmarking, industry average data, and material evaluations made in design. EPDs can be requested for carbon intensive materials such as concrete, steel, wood, insulation, facade, and finished products. Requesting EPDs from manufacturers only increases the amount of data available for benchmarking. And we can incorporate performance specifications, which can encourage innovative solutions and are beneficial for reducing embodied carbon in concrete mixes. In construction, we can perform submittal reviews to make sure that submittals are meeting the impact reduction goals set in design. To wrap up, by studying and comparing against benchmarks, we're able to evaluate and specify materials to reduce embodied carbon in design. I'm excited to see the transformation in the industry, and I think collaboration and transparency is key right now. We're still in the infancy of movement, and we can continue to move the needle by creating more data. And that being said, we can all encourage to push for more data in the industry to make our benchmarks more available and more accurate. We could request EPDs from material manufacturers and provide whole building embodied carbon data to organizations that are working to provide benchmarking databases. The more data we have, the more information we all have in tackling the issue of embodied carbon in the built environment. Thank you. It's my contact information if anybody has any questions at a later date. Right, pass it on to Lauren to talk about the SE 2050 Commitment Program.
Great, thanks Kirsten. So my name is Lauren Wingo. I'm a senior structural engineer here in Arup's Washington DC office. And today I'm actually going to be speaking from my role on the SE 2050 Leadership Committee and talk about the SE 2050 or Structural Engineers 2050 Commitment Program. So I think this will be really informative if you're a structural engineer that's part of a firm considering joining the program, or if you're just within the AEC industry and want to understand different initiatives underway to look at embodied carbon. So just to highlight the impact of structural materials, I think probably everyone on this call has seen some of these figures before, but as a reminder, about a quarter of global emissions are associated with the production of building materials, specifically structural materials. Next slide. And then at Arup, we did a study a very long time ago now where we actually looked for different building types to understand the contribution of structural materials within the embodied carbon. So thinking about structure and enclosure, what percentage is actually associated with structural materials in terms of the embodied carbon. And you can see that that range typically is at least half, it can be up to 60%. So in terms of the role that structural engineers have in addressing embodied carbon, it's very significant. And this is really the impetus behind wanting to form SE 2050. If you're familiar with AIA 2030, the way that SE 2050 was developed was very similar. We kind of followed what had been done previously. So for AIA 2030, they developed that program in response to a challenge issued by Architecture 2030. For SE 2050, CLF issued the challenge, which was for all structural engineers to understand, reduce, and ultimately eliminate embodied carbon in their projects by 2050. That challenge was issued formally in the summer of 2019, and it was really important that SE 2050 as a program was developed within a structural engineering industry association, because ultimately it's structural engineers participating in the program. The program needs to be based around the needs of structural engineers and structural engineering firms. So we're underneath the umbrella of the Structural Engineers Institute within ASCE, and the SCI Board of Governors formally adopted the challenge in December of that year, December 2019. So that was the challenge, and then in response, we as a committee developed the SE 2050 commitment program, just to distinguish between difference of the challenge and then now the program that's as a result to achieve what the challenge put forward. So we formally launched our program at Greenbuild in 2020 virtually, and at the time we also released our website. So it was pretty quick turnaround from late 2019 to then fall of 2020 to having our program formally launched. And we've had a lot of success to date. Already we have a lot of email subscribers, so a lot of people expressing interest. We participate pretty heavily in the CLF's online forum and also help facilitate discussions there. Of the firms that have expressed interest in joining the program, we already have over 30 committed firms, which is great. This list here isn't even the most up to date because we have people joining, every week. And originally our goal was 50 by the end of this year, and we're well on our way to achieving that. I will note that a lot of local structural firms are on this list, which is great. So I see some other structural engineers on the call today whose firms are already committed to the program. Okay, we like to include this slide whenever we give an overview to SE 2050 because there are a lot of questions we get. There's a lot of questions that the industry has as a whole. Some of it can come from maybe just not having that understanding yet of what embodied carbon is, maybe people being dubious about actually achieving net zero by 2050, or people that just want to understand how this is going to impact their day-to-day operations. So part of what we're doing within SE 2050 is to make sure that we're responding to these questions and helping to support structural engineers. If we look at the ecosystem of addressing carbon as a whole, AIA 2030 is really founded upon looking at operational carbon. And we're sort of, the other component of that, looking at embodied carbon, specifically looking at embodied carbon for structural materials. But the pathway to getting to zero in many ways is similar to what AIA 2030 set out to do. And it's through a variety of improvements to design, improvements to material production, helping to advocate for greening the electrical grid, considering the use of offsets and things like that in order to get to net zero 2050. And in conjunction with AIA 2030 goals, that would mean buildings as a whole through operational and embodied carbon are net zero by 2050. Okay, a little bit about the actual program mechanics behind SE 2050. If you are a structural engineering firm interested in participating, we have three main requirements as part of the program. The first is, if you are interested, we ask that once you join, you submit a commitment letter from your firm leadership. And this is really to make sure that leadership itself is expressing the commitment to the program. Within 6 months, we ask you to submit what we call the Embodied Carbon Action Plan. I'll explain this a little bit more in further detail. And that's a living document that gets annually updated so that you can look back on what you did the year before and think about further improvements. Another key aspect is a reporting requirement. So we ask you within 1 year and then annually to submit data to our SE 2050 database. I'm going to be explaining that a lot more. That really ties into what Kirsten was explaining in regards to benchmarking and data collection. So I've provided a link, sorry, on that previous slide, just if you are interested, the information with further details is on our website. Okay, so this is the Embodied Carbon Action Plan program requirements. So there are a couple components to this, and within each category, there are some mandatory requirements as well as some electives. And really this is outlining the requirements of the firm participating in the program to make sure that you are an active participant. So the first part is education. We really do want to raise the awareness of the topic of embodied carbon within the structural engineering industry, and really helping push for just more training internally to help raise that awareness. We also ask for a reporting plan to help understand how firms will plan to track the embodied carbon on their projects and then submit that data to SE 2050. We want to ask the firms about what reduction strategies they have in place on projects. So thinking about practical applications of the reductions that we're all trying to achieve. And then the last part is advocacy. We want structural engineers to be part of the conversation on embodied carbon. So one of the things we do is we help encourage people to join CLF hubs like the one that we're all on the webinar for today. Next slide. So in exchange for joining the commitment program, there's multiple things that SE 2050 offers, one of which, of course, is a number of resources that we have available on our website. We also have some publications that came out of the larger SEI Sustainability Committee previously that are really good references if you are a structural engineer or really anyone within the industry that wants to better understand things like performing whole building life cycle assessment and different structural strategies to look at life cycle assessment, just general overviews to the topic of structural sustainability. One resource that's more recent that I really wanted to highlight is this Achieving Net Zero Embodied Carbon in Structural Materials by 2050 white paper. I've included a link to this as well. This really answers the question, that people have about how do we actually get to net zero by 2050. And this paper is great because it outlines a couple of different potential pathways to get there. As I mentioned before, it can be through things like design improvements, just improving the efficiency in our designs, getting the electrical grid greener, always helps in reductions in any way. Improving material production, thinking about new different proprietary technologies and how that can be incorporated into material production. And then the other part of it, the supplement to get to net zero is always through carbon offsets. So if you have questions about, how we can actually achieve this, I would recommend reading the white paper. These are a couple of the resources that you'll find on our website, and we've gotten a lot of positive feedback on these. So we know people in the industry are already adopting them. The one on the far left, embodied carbon intensity diagrams. These are studies that were done, I believe, on 4 different types of structural systems, just looking at a typical structural bay and understanding the embodied carbon of each of those bays. And what's great about that study is that it was done by multiple structural engineers. So it shows a range in terms of the structural design itself. And it was also done by people using multiple LCA tools. So it also accounts for a wide range in terms of the LCI data sets that tools use to acknowledge that what we're always talking about when it comes to embodied carbon for the most part is the magnitude of each of the different design decisions that we're looking at. ECOM, the embodied carbon order of magnitude tool, is a really quick tool to use that uses industry average EPDs for structural materials. And what you can do is go to our website and fill in your quantities for the different materials, and it will output your GWP. This is A1 to A3 because it is based off of EPDs, but we find it's a really good, quick tool. It's been helpful in just raising the awareness among structural engineers in terms of looking at embodied carbon. And then last one on the right, in the future, we will be publishing embodied carbon benchmarks. I'm going to explain a lot on that topic more towards the end. So the embodied carbon benchmarks that we are going to be developing will be based off of the SC 2050 database. And that is our reporting tool for firms committing to the program. I mentioned previously that we're going to be asking for them to submit data annually into our SC 2050 database. This is currently in development. We're really excited about it, and it's launching in June, so only about a month and a half from now. A little bit of a background of why we felt a critical component of SE 2050 was to develop a database for embodied carbon. As probably all of you are aware, the current approach to how we perform whole building life cycle assessments is through a comparative whole building LCA via the green rating systems such as LEED. They would require you to compare your as designed building to a reference building and demonstrate improvements. Next slide. So the challenge with the current approach is that if we're trying to achieve net zero by 2050 and looking to this over time, and you're doing a comparative life cycle assessment to design options you're considering internally within your firm, it's not really making a comparison overall to where we need to be as an industry. So it could very well be that that building design that you're proposing is performing well relative to the current industry benchmarks. Next slide. Or of course, it could be performing worse. And then it could also be the case that you have your building that you designed in 2020 and 2030, you're using the same design and you're not improving, which is what we're trying to achieve as we get to net zero. So it's really important to be able to make comparisons to industry benchmarks rather than just internal comparisons between two options. Next slide. So in the future, where the industry is heading and why everyone keeps talking about benchmarks is because we want to shift over to the concept of still a version of comparative whole building life cycle assessment, but in this case, comparing your project to an industry-wide benchmark. And in order to do so, what you would do would be perform the LCA, report into a centralized database like SE 2050. The output would be your comparison to the benchmark, and by feeding into the database, it creates this continuous feedback loop where we can update those benchmarks, give you better comparisons as we all seek to achieve net zero. So whenever I talk about embodied carbon data, I always like to highlight that there's no such thing as an embodied carbon meter that you can stick on the side of the building. Unfortunately, for operational energy, of course, they have the luxury of having metered data. And because of that, they have CBEX, which is a great database and provides a reference point for anyone wanting to understand the energy use of a building. They can refer to that database. But for embodied carbon, there's no CBEX. And so SE 2050 is really working to fill that void. So in the future, you know, what we hope is based off of the data being reported to our database over the next year, that we'll be able to develop these industry-wide SE 2050 benchmarks against which projects can be compared. So the version of the database launching in June will be our beta version. And I wanted to highlight a couple of the priorities that have led the way of our database development. First and foremost, SE 2050 is a program built on raising the awareness and education of structural engineers, and part of that is certainly to familiarize structural firms with embodied carbon reporting, getting used to different workflows of collecting embodied carbon data on projects, and then how to report that, getting used to what the magnitudes and values are that they should expect out of their different projects. At a minimum, we really want to focus on collecting global warming potential data. I'll explain this topic a bit more in detail, but of course, what we're going to be reporting out are embodied carbon intensity benchmarks, which are based off of GWP data. So we need to make sure that we're collecting that at minimum. And then lastly, I think a big part of what CLF is doing, what we're all doing here, is just increasing awareness in the industry as a whole and beyond about the importance of embodied carbon. And for SE 2050, certainly a part of that is raising the visibility of the need for industry-wide benchmarks. So, you know, by collecting data, even a smaller data set or limited data set within the first year, if we can demonstrate the fact that we can create these benchmarks, they are needed and are being used, that it will help attract focus to that need. So fortunately for us in developing the SE 2050 database, we do have a number of precedents that we can refer to. I mentioned AIA 2030, of course, in the development of our program as a whole, but also the AIA DDX database helped to allow us to envision what SE 2050 database could be. Within North America, there were two previous efforts of looking at an embodied carbon benchmarking database. Carbon Leadership has one that they did in 2017, here on the right. And then DECO, this was a PhD thesis research project by Catherine DeWolf, and she developed a database that looked at structural materials specifically and embodied carbon data reporting. Both of those previous benchmarking database efforts were with a discrete amount of data. So they collected data when they were developing the database and used that data to develop the benchmarks, but there wasn't that continuous feedback loop that we will have as part of the SE 2050 database. RICS in the UK, they do have an embodied carbon database that's available now and does continuously update based off of information people provide to the database. What differs from SE 2050 and RICS is that we are tied to a commitment program. So we do have that reporting requirement to firms, which means that there's a mandatory reporting requirement, and we will have a continuous stream of data, whereas RICS is more optional reporting. So in terms of what data is being collected by the SE 2050 database, to get a little bit more into the nuance of it and understand what we will be asking of structural firms, we're asking for information that describes the structural system. We're asking for general project descriptors such as location and building use type. And then of course, we're asking for the LCA data, so the GWP, tying that to an LCA tool so that we're making correct comparisons, understanding what stages were included. And really all of this data that we're collecting is to make sure that we have the ability to set appropriate benchmarks. I always give the example that we wouldn't want to compare a building that's in a low seismic zone to a high seismic zone, because there has to be acknowledgement that GWP factors vary based off of different structural design criteria that may require more material intensity and therefore potentially more GWP intensity than others. And of course, what gets output from all of this is embodied carbon intensity, which seems to be now the industry-wide adopted term. And we report that out in the units of kilograms CO2 equivalent per meter squared. So kind of similar to what Kirsten was saying about EPDs reporting on a per unit basis of kilograms CO2 equivalent per unit at a product level. Since SE 2050 is at the whole building level, we report it out with our unit basis being meters squared. Okay, so I wanted to highlight to those on the call the various whole building benchmarking initiatives underway. And again, there are those product level benchmarks that Kirsten covered, and this is focused at the whole building level. So EC3, Embodied Carbon and Construction Calculator tool, it is looking at EPDs and collecting A1 to A3 data. They do plan to do benchmarking at the whole building level. I think that that's currently in development, so we may even see that later this year. AIA DDX now has the option to collect embodied carbon data, so you can report that in as part of your project reporting. EC3 and AIA both look at structure and enclosure. EC3, structure enclosure, and then some if you include your interior finished materials. For SE 2050, reminder that we are focused on structural materials, so it's structure only. Similar to AIA, we're focusing on, trying to collect that whole building LCA, so looking at modules A through C specifically. So I think, for those of us on the call who are really nuanced in life cycle assessment and all of this, I think it's important to understand the differences in terms of the data collection of each of these benchmarking databases and what that means for the future of what data we'll have available to us. So for the beta version of the database, this is kind of a little diagram to show how it all will work. structural firms that are committed to the program are going to report into us the GWP data. We will collect and aggregate that data and work with an industry roundtable in order to develop benchmarks and targets. So we plan to be working with CLF and other primarily academic organizations that can help with that benchmarking effort to make sure, as I mentioned, that we're creating appropriate benchmarks, statistically significant benchmarks, all of that. And then that provides us the ability to report back to structural firms that are participating in the program what their performance is relative to the benchmark. And that helps them meet their commitment goals in terms of that embodied carbon action plan I was describing earlier, and helping firms reflect on how well they performed within the past year and what they could potentially do to improve in the future as we seek to achieve net zero. So there are large data variability within the LCA industry as a whole. We know a lot of this comes from different LCI data sets, since we don't have a publicly centralized LCI database that all the different LCA tools use. So instead, we have these proprietary data sets that vary a lot, and that creates a lot of variability in the results. So in the CLF benchmarking study, they saw this. They collected from a bunch of different projects that use different tools, included different life cycle stages, probably had different functional equivalencies in terms of what was included in their studies. So you see there is a ton of variability, and that's a reality of the industry at present. Certainly part of what we're doing within SE 2050 is trying to collect as much data as possible in order to help reduce that variability. Another way that we think SE20 and structural firms can help towards reducing that data variability is to focus on what we know at best as structural engineers, and that's the structural material quantities. So certainly in the future, as we further develop the database, one thing we're interested in looking at is having firms submit structural material quantities. And what that does is it allows us to use a single backing LCI data set against those material quantities, so that we're helping reduce that variability and potentially using the same backing data, which means we don't have as much variability on the kind of LCA side of things, and getting consistent structural material quantity reporting in order to reduce that variability. But essentially the way that it's structured for structural firms reporting to the database would be the same. Instead of GWP, we'd be focused on structural material quantities and still report out the benchmark. So with that, that's the end of my coverage of SE 2050, and I'm happy to answer any questions people have about the program overall.
Lauren, I think there's one question in the chat. It's from Joel. It's how is typically cost be evaluated in all the design phases parallel to carbon impact evaluation? It seems to require close involvement of a GC.
Sure.
Yeah.
Yeah, that might have, Kirsten, do you want to help answer that? I have some thoughts as well. That probably ties in more.
Yeah, I think I saw it, and Joel, please feel free to jump in if you have any more clarity on it, but I think I saw it come in response to one of your slides, just in but.
Okay, yeah, I can respond to that. So, I mean, I think in terms of, as a structural engineer for cost evaluation of different embodied carbon reducing strategies, in my experience, and I think on the previous CLF webinar that was focused on concrete and specifying concrete materials, that if you're properly specifying your the cost premium to low carbon concrete. And I saw some suppliers on the call. From my understanding, if you've implemented things like carbon cure technology, there's like an upfront capital cost, but it's not really seen at the project level to us. So in my experience, I haven't seen cost premiums if we're properly specifying low carbon concrete during design. The issue becomes more if you do it retroactively in construction and get a change order.
Yeah, and I think to add on to it from the sustainability consultant perspective, I think it's important to involve this conversation in the pre-construction effort as well, to make sure it's part of the conversation at each of the pricing points that go on from a GC perspective through the design phase. You're muted.
Oops. I've heard from some structural engineers that when they do want to incorporate these cement management practices or look at their concrete mix designs, they want to make sure that anything that they consider is in the permit set or the GWP for pricing, and making sure that, you know, when the GC does review that drawing set, all of that information is in there for the concrete mix design. So it is priced out when they are looking at the drawing set.
Looks like we have another question. And Joel, please feel free to jump in if you have any follow-ups to that. But the next question, is the program US specific or open to international participants?
Yeah, that's a good question. So SE 2050, we are underneath the umbrella of the Structural Engineers Institute. So we are a US-based nonprofit organization. However, we do acknowledge that there's a void of embodied carbon benchmarks, not just in the US, it's everywhere. So we are developing the database in order to allow for reporting on international projects. In terms of signing on to the commitment program formally as an international participant, that is something that we're considering. So if you have follow-up questions on that, reach out to me. And I think that that's some guidance that we'll be giving soon, since we've gotten that question previously.
Does anybody else have any other questions? Okay.
Hello, this is Joel. Do you hear me by chance?
Yes, we can hear you.
Yeah. Hi, sorry. Yeah, as a follow-up, I was wondering when one evaluates different options at the early design phase, for example, using different structural systems or using some CMU instead of some concrete, or all those options, I would imagine that an owner would be kind of anxious to know if those different, what those different options represent in terms of cost, since it's an early design decision. So I wonder how is this done, like in the background, like behind the scenes, usually in your experience, or does it involve a close discussion with the client and the GC to make sure that to be transparent about the options considered, and then tell them that this option is less carbon intensive, but it costs 2% more, or this kind of consideration?
Yeah, I think at the system level, in a way, structural engineers were already trained to choose the most efficient system for the given project, which considers material efficiency, which relates to cost and also relates to carbon. So in a way, I think at kind of like the high level of system choice, that by nature of choosing the most efficient system, you're choosing one that's cost effective and carbon effective in a way. I mean, I think more and more firms are starting to look at those easy GWP numbers, even in early schematic phases when you are considering different options in order to help better, I guess, be transparent about that trade-off. But I think I always focus on, as long as you choose the most efficient system, there's always going to be strategies specific to each system type that you can further implement as you go along in design that really can help reduce your embodied carbon impact without major cost implications.
Okay, that makes sense. Thanks.
We're planning to dive into some of those strategies that Lauren is referring to, hopefully in our next session with the Washington DC CLF group. I think we're planning to have Michael Cropper with Thornton Tomasetti come on and talk about some of those great strategies that structural engineers can implement in design.
Yeah, I've even seen Kate Simonon present on this topic, and I think she feels the same way about, you have to choose the system that's most appropriate for your project. It's not that all buildings are going to be built out of timber. That is not going to be the most carbon effective solution for each project, depending on what the needs are. There's always going to be strategies no matter what system or material is chosen.
Great. Oh, we had another question come in. Would you see these benchmarking programs facilitating regulation similar to operational emissions in the future? For example, in the EU, we have building energy certificates ratings that rate operational emissions A through E grades. Has this been something you've looked at? I think this is in reference to the SE 2050.
Yeah, so I guess, part of the way the data and the benchmarks could be used for in the future would be for legislation. It's not something we're specifically looking at, since we feel that our role and responsibility is helping move the structural engineering industry forward and just providing a database for that reporting, not necessarily looking at legislative implications. I do know that for the Buy Clean Acts in the US, that some of those are also looking at different benchmarking initiatives, and that is already building legislation. I think we can expect in the future that any embodied carbon benchmarking database will potentially be used by different jurisdictions for legislation.
Great. There's another question that came in. As an architect, or is this a question? Yeah. I'm super excited to see more on the SE 2050. What can architects do to help our engineers in reducing embodied carbon? What can we do to help our engineers in the SE 2050 reporting efforts?
Yeah, that's a good question. So I think the first thing is helping advocate for looking at embodied carbon in the first place if the structural engineer you're working with might not otherwise be considering it, and definitely encourage them to participate in our program if you can. In terms of helping engineers in the reporting efforts, again, I think it's more about advocacy, and the more we can even do within the industry to help improve those LCA tools, the LCA data, and making it easier for us all to be tracking that data and reporting data will be helpful.
Great. Another question, is the white paper that was mentioned in the slides the best set of design examples to use when explaining embodied carbon to an owner?
Yeah, I think that there are, a couple of different design aspects that are highlighted in there. There's also one that's listed in there that's a whole building life cycle assessment reference guide for structural engineers, and that goes over a lot of different strategies and then how you can implement it on LCA. So it could be things like, you know, we keep talking about concrete because that's an easy one, but also stuff like design for deconstruction, designing for resiliency, using salvage materials. So I think that's pretty comprehensive in terms of structural strategies, and I would recommend looking at that reference guide instead.
Great. Did we have anything else to go over today? Okay. Well, I appreciate
we do have Lauren's quiz questions if we want to run through those for the last couple minutes here.
Sounds good.
Okay. So maybe this will be a bit of a quiz for myself too. Okay, so these are the embodied carbon intensity diagrams I mentioned earlier. So I think I misspoke earlier when I said it was 4, it was 3, steel, concrete, and timber. And what we did was we looked at typical structural bays and the different systems that you see with each. So just like conventional steel beams and composite metal deck, a post-tension slab, and then CLT over glulam. Next slide. These were the results from those studies. And I mentioned earlier that it was a number of different designers looking at this. So it was a variability even just in the structural material quantities. And then we ran it through multiple LCA tools. There's also variability in that LCA data. Oh, you can see on the previous slide. Typical system weight for a structural system is around 50 pounds per square foot. And then as a result of our study, there was a range because of all that variability and how the data was collected, range from 19 to 27 pounds per square foot of embodied carbon. So like if you want to ballpark it for embodied carbon intensity of a steel structural bay, it's around 25 PSF. Next slide. And PSF is kind of a weird number, I think, for embodied carbon, since the metric we are typically using is kilograms per meter squared. But I think in terms of relating that back to the system weight is a good number for structural engineers to get a grasp of, and then you can always do the conversion on the back end. So for concrete, heavier system, sorry, here's some previous slide, I'll let you know for the next one. So heavier system in terms of the system weight itself, and then also in terms of embodied carbon intensity, which I think we would expect, again, a range of 25 to 37, but let's say this one averages more like 30 PSF for concrete, more than that 25 we saw for steel. Okay, so then if we get to timber, which is the next slide, yeah. So what do people think the embodied carbon intensity is for timber? Steel was 25 PSF and concrete was 30 PSF. So maybe if you can enter into the chat some guesses. And don't be shy, because I mentioned there's a lot of variability in this stuff, so. Any other guesses? Okay, these are good guesses. Okay, Joel's skipping ahead to the answer. So we can go to the next slide. So it does vary a lot because we know the LCA data varies. So if you're not considering biogenic storage, it's close to 20 PSF, which I think is interesting. So it is overall lower than steel and concrete, 25 and 30 respectively. But I think sometimes people think timber, because of carbon sequestration, is zero, basically. If you do consider biogenic storage, that would be negative, so -5 TSF. Of course, there's a lot of discussions on how we treat biogenic carbon, but that alone, considering different LCA practices. Okay, and then if you go to the next slide, we'll close it out with one to further highlight the impact structural engineers can have in reducing embodied carbon. I like to show this one a lot to students that I present to because they find it pretty fun. So for this conceptual project, let's assume that you have 100 concrete trucks delivered to site and that you're achieving 20% carbon reduction in concrete mix, which is very achievable. So not even like that crazy big of a project, 20%, not that crazy. How much do you think you can achieve? The next slide. And we'll relate the reductions in terms of how many cross-country flights you would have to avoid in order to achieve the same offsets. So this is to try to think about the decisions we make in our personal life that we think have a huge impact on embodied carbon relative to what we could do as building designers. So how many cross-country flights would need to be avoided to achieve the same carbon savings? Okay, giving a range of answers. Other guesses? Okay, if we go to the next slide. Popular answer, a lot of people got this one right, which was good and probably speaks to the expertise in this group. So yeah, 25 flights. When I heard that, I mean, it's kind of crazy. Like you could work your whole life on your personal decisions to try to offset even changing the concrete mix on floor of your project's construction. So keep that in mind. And that was it for the quizzes.
Well, thank you very much. This has been very helpful information. And thank you everyone for joining, and please feel free to reach out with us with any follow-up questions. If anybody would like to stay on and potentially discuss any options for future networking groups, please feel free to stay on and chat with us. Thanks. Thank you, Lauren. Thank you, Kirsten.